Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Saqif bin Muzamir and my metric number is 211362713. Okay, so in this video, we will discuss about Lab 4, which is frequency response Bode plot. Okay, so we move to the number 3, procedure. So procedure 4.1.1, we need to derive or determine the circuit transfer function for the RLC circuit, and then after we done derive the circuit transfer function, we need to cascade the RLC circuit with this Ks, which is the value K is given. We need to use the K equal to 0.1. Okay, so by plot the system Bode plot using by MATLAB, obtain system gain margin, phase margin, gain crossover frequency, and phase crossover frequency. Okay, so this is calculation for derive the RLC circuit, and then after we done the derive, we put the code in MATLAB. So the numerator is K 0.1 and the denominator is 4410. So G is for the transfer function, numerator, denominator, both to get obtain the Bode plot. So we run the code. Okay, so this is our Bode plot for the procedure 4.1.1. This is for magnitude and this is for phase. So to get the phase margin and gain margin, we need to select characteristic and all stability margins. Okay, so the dot will appear and the line. So we need to click at the dot and the dot for phase. So we can see the system for procedure. Gain margin is 20, frequency radian 0.5, and the condition stability of graph is stable. So we can see the actual value. Gain margin is 20 dB. Then for phase margin, we get 68.2 degree. And for grain crossover frequency, we get a 0.5 radian. And for phase crossover frequency, we get the 0.0964. So both for the magnitude and phase is stable. So for 4.22, we use a same method, but the manual we will using a similar graph paper. Okay, so we move to the exercise 4.1, which is if K is equal to 100. So we need to the substitute and derive the transfer function for this circuit, and we substitute the value. So we put the value, numerator is 300, denominator 1, 57, 360, 500 and 0. So G is transfer function and Bode. So we run the code. Okay, so this is graph for the K equal to 100. We select all stability margin. So the question asks we to determine gain margin in dB, phase margin, gain crossover frequency, and phase crossover frequency. So for K equal 100, we obtain the gain margin is 5, the frequency radian is 70.5, and for phase margin we get 96.9 degree, and frequency for phase over cross 0.681. Both the magnitude and phase for the K equal to 100 is stable. So for question C, the question asks us to obtain on the same Bode plot when K is 50, 500 and 1500. So the method is same. We need to change the value K only. So after run it, we will get the for magnitude and phase, we will get the stable condition because the value of K is positive value. So that's all from me. Thank you.